Hey everyone, Sean, having fun repairs. Welcome back to the channel. What I have in front of me is a Class D monoblock car stereo amplifier, primarily used to amplify a subwoofer. So low level, well, I wouldn't say low level, low amplitude audio, but to take lower frequency audio and amplify it to a subwoofer. This one comes in from a customer. I marked it as no power blown caps. That's what the individual said. And so why don't we just take this apart and have a look at what's going on inside. As a matter of fact, if I move it and listen, I can hear some things moving around. Let's take it apart. Caution, no user serviceable parts, I assume, inside. Yeah, we're going to test that theory. Oh, now that I have it apart, look at the carnage. Looky at all that carnage. You can see it's splattered everywhere. Just on the side, you got on this case, on the lid over here. It's down in here. See all that? So this is what happens when you have some pretty massive caps, literally vent. And they're fully cracked open. These things vented bad. Yeah, you've got no power. The question is what came first? I went ahead and did a little bit of poking around with my multimeter, and I'm kind of concerned. So the center of this right here, these are what, K7812, 7815 is over here. They're both positive voltage regulators. Maybe one's negative voltage regulator. I don't know. But either way, pin 2 is the ground, right? And look, we've got there, that one leg on our N-channel MOSFET shorted to ground on this side. And if we were to check over here, yeah, we should be reading like a diode. Okay. My arm was in there. Here we go. You see that right there. Oh, that was the center channel. Or center pin. So you can see that differences just right there. That one does okay. That's okay. And a direct short. Okay. Direct short. Okay. Direct short. So if I have to replace these, I'm going to do all three in series, including this voltage regulator as well. All this is going to have to get cleaned up. These caps right here will have to get replaced. That's at a bare minimum, and I think that would get us back working. Now, I don't know if these are shorted out because these caps are blown, and maybe they're shorted out in center. That's always a potential. But this is the side that we, and the crazy thing is none of these fuses on the side blew. There's 30 amp fuses in all three of those slots. I don't know if that's what needed to be in there. I'm not too sure. But if I got to replace these, replace these two, I might recommend go ahead and replacing these capacitors here and these here. But at a minimum, these two caps here and probably all four of those components right there. Alright, I need to get this priced out and get with the customer. Let them know my recommendation. So And then barring, of course, what happens with that, we'll come back and do some more work. Well, I've gotten all the parts in that are going to get replaced, and I went ahead and started to clean up, dismantle, disinfect, dissect, and really try to get rid of everything that exploded out of these capacitors. But little note, you can see I've removed the insulators, plastic. You know, sometimes this will be a mica sleeve. I think these are just plastic. From here, make sure if you, and I'm going to be replacing with new thermal compound. That's why I'm cleaning up through here anyways. Make sure that these get back so you don't short out all your components here against the chassis. They have to be insulated, otherwise you're going to have a very bad day. Now, I've typically found a lot of people don't like to get heat sink thermal compound on them. It's kind of hard to get off of your skin, I guess a little bit. It's definitely hard to get out of clothes. A lot of people, when they are cleaning thermal compound off of, say, a microprocessor, or in these amplifiers, they like to use Q-tips and rubbing alcohol to do the removal process, and there's nothing wrong with that. I've always found, just get yourself a cloth or a Q-tip and just rub it off. Don't use any alcohol, and that's always worked best for me. And I feel like it's often a lot quicker than the alcohol method, which kind of smears the heatsink compound around. But anyway, so all this has been cleaned up, and I cleaned up the board a bit too. So what I need to do now, and here's where my thoughts are at. Okay, I'll get all this out of the way. All right. Now, I probably could just go ahead and remove this, but that's glued into the board. Whatever, I'll leave it attached. I need to determine if the reason why these components are shorted out is because of these exploded caps. So I'm going to go ahead and remove these and recheck these components. So that's the next step here. These old blown up caps out. If you saw me feeding a wire through, so there's 2 layers to this PCB, truly, top and bottom layer. And the one thing that you got to take note of when you got these big old capacitors is typically the top layer should be connected with the bottom layer through hole. And when you take these out, if you're not careful, I did it on one, you can actually pull out the inner pad that takes you from the top to the bottom. So what I was doing was I was just feeding a small wire through the hole on each one, just to make sure we have, just to make sure that we can conduct through the pad to the other side. And yeah, make sure electron flow goes the way it should go. Anyways, for, I guess, poops and giggles, we can check the value of these exploded caps. 220 microfarad, or 2,220 microfarad, so 2,200 microfarad. And what are we reading? So 2,400. I mean, if this was a 20% cap, you might think that was good. That yeah. Ooh. Yeah, super leaky. Now, you can't do a resistance check on all caps to determine how leaky they are. You really need a LCR meter or something along those lines. Something to actually check leakage on a cap. But sometimes it can give you an indication. If you saw the video with the plate amp, the Polk amp that I repaired, you saw me do this, and oftentimes even with bulging caps, which you know are leaking, especially as they heat up, those caps are no good. You can still measure okay on the capacitance value, and with a resistance check, typically high ohms, so 1628, so that could be within 20%. I'd have to do the math, but you know, even if it was, obviously this capacitor is no bueno. Okay, completely exploded up top. Let's see, is this going to give me high resistance? Yeah, so 2 megohms. I mean, you might think that'd be okay in comparing it to a replacement. Actually, let me dig out one of the replacements I have for it. I think I got them right here. See, these were the 220 63 volt. Yeah. As I'm feeling this side, those feel like they're, at least that one feels like it's slightly bulging. We're going to replace all 4 of these. And we'll replace our filtering caps as well. Got these off of Mauser, and it's pretty typical for what I do. If you need a part number, go ahead and pause the video. And is that focused? Here, I'll do it like this. It's probably going to be backwards. Either way. Zoom in, I guess. There's your part number right there. UVY, or Uniform Victor Yankee 1 Juliet 222 Mike Hotel Delta. Manufacturer part number. Anyhow, get that out of the way. Yeah, we'll do a full. So slightly taller than the original, but I don't think that's so tall that we're going to run into an issue with our case. These are Nichicon, and I like Nichicon. Instead of being snapping caps, these are through hole, which is perfectly fine. And these would just go in just like this. But here, let's just do a quick resistance check. So 3K and low ESR, I guess. So you'd probably think that the other cap was superior on that check, but no, they're not. They're obviously exploded. What are we getting for capacitance? There we go, 2117 microfarad. Okay. So I'm going to go ahead. Oh, let me go ahead and check diode test. Do we still have a short on these guys right here? And yep, yeah, we do. So yeah, we're going to end up replacing all of these. Yeah, go here to ground. Yeah. Just checking those caps right there. That should be short. Now, all of them being shorted together could indicate something else around the board causing those in to be short. I'm not too sure. I don't know the topology. I don't have a schematic downloaded. But we're going to replace them anyways because this is the side that we are seeing that issue with. And as a matter of fact, if I was to do a diode check over here on these, you know, and then come down and mimic on this side of the board, the behavior is exactly the same top and bottom. Here's where it's the only difference. So yeah, let me get to work getting. I'll get these four caps replaced. Probably time for them to go. These two, these soldered in, and I need to get these out and replaced as well. That's what I'm going to be doing until further notice, I guess. Let me get to work on that. So I've replaced the caps and I've had a bit of prodding around after viewing the bottom half of our circuit board here. And it now does make sense why these are shorting, because they're all essentially tied to the same path. If I was to follow this around, you'd see it come up here. We got jumpers going across here. So that means that this center pin would, in fact, be shorted to over here. If I get a good connection, there we go. Of course, this being on our suspected bad components. And the more I think about it, it does kind of make sense now, because I am under the assumption that we have a positive and a negative voltage rail. And so we're operating these in, say, a push-pull configuration. And so even though the components are the same on each side, what is presented to the pins is going to be slightly different because you will have a negative voltage rail versus a positive voltage rail. All that being said, still if I, in diode mode, let's say center pin to here, 0.7 center pin to this side, 1.4. So over here I expect to see 0.7 and 1.4, and it's a bit different. These are now reading the same, probably as I was, you're presenting a battery current from your multimeter into the board. It probably charged up some capacitors. But let me go the other way now. Let's see. And of course, this isn't really the right way to test these with them inside the PCB. But 0.47 voltage drop, center to essentially the right over here. So I imagine I see, essentially 0.5, 0.47. I think that would be the same. Over here we've got 1.7. Of course, that's increasing. So what is that over here? So over here it's showing discontinuity. Okay, we're showing over a little bit of a charge right there, and then so again, not being very familiar with the topology of this board, and not having a diagram in front of me to really go off of everything. I think I'm still going to just, and these could be good. I'm just suspect. So here's what I have to consider. These capacitors exploded. These two right here exploded for a reason. Was the reason because of these? I don't know. Still concerned about the fact that the fuses over here did not blow as well. Okay. I have some disparity between one side to the other. So I think, as a precaution, because I could probably at this point power this up, but if something's wrong because of these, I run the risk of detonating these caps over here. I'm hesitant, and that's all I'll say about it. So I think I'll just go ahead and replace these, and then we'll power it up. And if they happen to be good, then they happen to be good. But at least that keeps me from running a risk. I feel like I have a very real risk right now powering it up, not knowing what causes caps to physically blow. And so I'd rather just go ahead and replace everything, our positive voltage regulator and our IFR 640 N-channel MOSFETs over here. Well, with the components down, I guess we can do a multimeter quick check or test at this point. I did replace this KA7812 positive voltage regulator with a sub, a UA7812 6KCS linear voltage regulator. It's also positive voltage regulator. I believe that is a good enough suitable sub. Let me grab my multimeter here. I'll just put in a diode check. And I'll go to center pin here to outer pin. 0.2 voltage drop. Let's do it this way. 0.5. Slight difference. Oh no, 0.5. That one's going down. So is this guy leaky at that junction? Let me check this other side. Oh, you know what? I've got them on this ESD mat. Let me take them off for a second, just in case if that's creating any issue for us. Okay, try again. And unwrap my leads. Okie dokie. Here we go. 0.5. Yeah, that did make a difference. 0.9. Check from this side to this side. 0.5. 0.5. 0.9. So I think we might actually have an issue with one of the junctions on here. This being a positive voltage regulator means we got two diodes facing each other, if I'm not mistaken. I can't remember if they're common cathode or common anode. You'd have to look it up. Okay. But if I was to reverse these around, let's see what we get. 1.8 and open. Let's see what this guy looks like. Open and open. I wonder why that's so different. Well, I mean, we do know that that one's higher on that side, so that could be one of those disparities. So in-channel MOSFETs, this really isn't the best way to test them, but we'll do the same thing. See, positive center pin, outer pin, nothing. Nothing. What about left side? Nothing. Nothing. Now I'll swap them around. .5 and nothing. 0.5 and nothing. So these in-channel MOSFETs might be okay. Actually, you know what I forgot to do? I forgot to do outside to outside. 0.5 there. 0.5 that way. What about reverse? 1.5. 1.6. Okay. So if anything, I would say probably the voltage regulators bad, but let's compare these. 0.5. Open. 0.5. Open. And then of course if I reverse it, so long as we haven't charged the gate. Oh, wait a second. 1 and open. Let's see what this one looks like. 1.2 and open. Okay, yeah. They're the same way. Alright, let's do this again. Positive on center. Okay, open. 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 Now I bet if I reverse it, 0.5 and open, 0.5 and open. I bet it's charged now, so we might, if I reverse it back, we might get the 0.2. Yeah, we do. Yeah. All right. So to me, I believe we've got an issue with our voltage regulator. I don't think we have an issue with the in-channel MOSFETs, but given what I'm seeing with the voltage regulator, I think I'd go ahead and replace these anyways. I need to cut a bit of heat shrink, and I need to bend the feet to get them to approximately the same standoff, and then put them back in, and of course solder them, and then I'll get this all put back together, and we'll try to power it up. Now that I've got this back together, it is time to attempt a first time power up since the repair. I've got the second output channel of my uh, signal generator set to a DC output. Um, and then I've got this over here that I'm going to uh, turn up to 12 volts input. So the SIGGEN that I've got, instead of doing a sine wave coupled to DC output, is going to the REM. And then, of course, my benchtop power supply is going to provide my 12 volt reference. So what I'm going to do is, right now I've got the REM output off. I'm going to go ahead and just increase the current. Okay, and I'm going to take this up to 12 volts. Okay, and obviously there does not appear to be a. Where's my light at? I don't remember where it was at. I believe it was in. Oh, yeah, right here. It's being blocked. Okay, so I don't have an LED just yet, but I'll turn on my 2 output. Right now it's set to 0 volts. Not drawing a whole lot of current, so let's see what it takes to trigger that REM. All right, there we go. 5 volts has triggered it. I'll take it up to 6. We got blue light. All right, so as of everything right now, this is looking pretty good. Okay, I'm drawing half an amp. Now I've got all my tone controls and every single control at I think a minimum setting.
with the exception of my low pass filter. I believe I have it set to 300 hertz. Nope, I didn't. I had it at 32 hertz. We'll crank that one up. But my gain is at minimum. My bass boost at minimum. My subsonic is at minimum. And phase shift is at 0. Okay, so as it stands right now, we're powered up. We've got a blue LED. I think we're going to be okay to put in some audio. So let me work on getting that connected. All right, so I've got an input of 80 hertz, 1 volt peak to peak. Obviously, if it's coming from any form of CD player or whatever in the car, the input amplitude is going to be significantly greater. But I can't overdrive my benchtop power supply or this amp because it's a different kind of setup. So basically, what I'm doing is I'm going to check each input channel at a time. I've got that 80 hertz signal going into the left input channel, and I should have 2 outputs. So one speaker output's going to be here, and we got that 80 hertz at 42 volts peak to peak. And then the other one's here, 80 hertz, 42 volts peak to peak. So it looks like we're 42.2. Looks like we're very symmetrical on our waveform. I'll go ahead and clip this into the ground over here. Let me take this and put that little clip on. We're going to clip that there. Okay. Let's see. Is this adjusted? So I got my probe. I need to set the actual. It's not 42. I think I've got it in 10 by. Yeah, it's in 10 by. I just need to make that adjustment. Okay, there we go. Okay, so set my probe to 10 by. Couple of AC. Increase this up to 50 volts, and we'll see what happens as I increase my gain. I guess I could drop this down some. So at a 1 volt input, our max at gain is 22 volts. Is that going to be the same for the other side? Yeah, 2 volts for the other side. Okay, cool. Now, what happens as I adjust my bass boost? I'm at 0 dB. It definitely has an effect on the signal. Actually distorts it. Is that going to be the same on both channels? Yeah, it puts it into clipping. Wonder if I back off my gain a bit. Take it down to 64. Let's do the bass boost again. So that causes distortion and clipping when we go too high. But I guess that saves you on over amplifying just at the gain. operate in a clipping capacity. So our low pass filter is at max at 300 hertz. I'm going to turn it down to 32 hertz. And as we get closer to 32 hertz, that amplitude should start to decrease. And it does. Awesome. Cool. Great. I don't know what subsonic is, but it's listed between 10 and 50 hertz. Does this have a effect? Really any of one. I wonder if I drop my frequency down to, say, 40. Okay, you see that there. Now, does the subsonic have any form of effect? Yeah, it's like a boosted kind of range. Boost the amplitude a bit at that lower range. Just that specific lower range, 10 to 50 hertz. The other side, you go more predominant too. So at 50 hertz, when I turn it closer to 50 hertz, I decrease in amplitude. As I go to 10 hertz, I increase in amplitude, increase a bit in amplitude. So that's that's pretty interesting. All right, and then the other one's just phase. Okay, so it'd be hard to show this without monitoring the input as well, if the phase shift even works. Let me see if I can get a second probe attached, and maybe this will make sense. Right, so I got a second probe attached, one to the input, one to the output, and now you'll see what I mean by phase shift. The output should shift. Now, it might look like the input shifting, but it's really not. The output, which is the yellow sine wave, should shift in and out of phase as I adjust this or make this adjustment. Okay, so and no, the phase adjustment does nothing. So it's a potential that well, let me get out of 40. Let's go up to 80. As my oscope froze up, what's going on here? There we go. Updating now. Kind of weird. Let me try this again. Yeah. See, you see now. Like I said, it looks like the input shifting in and out of phase, but that's not what's occurring. It's the output. So we don't necessarily get 100% in phase with each other. Means that so that's roughly 180 out. We almost get exactly in phase, but not just. This isn't. I would not call this a high quality car amplifier. So yeah, you can see it now. It's not necessarily getting, so that's about 180 out of phase. Like I said, it looks like the input, the purple line, our output's the yellow one, is the one that's shifting, but that's not what is occurring. The output's the one actually shifting. We don't necessarily get in phase, but and I wouldn't think we would. This isn't an extremely, I don't know, is M whatever the manufacturer, M Lab, whatever this is. Maybe I don't think this is a high quality amp, but MMATS, MMATS for audio. Maybe it is. I don't know. But yeah, there you go. So this looks like, all intents and purposes, this that we're good. I mean, we got equal amplitude. Let me go to the other input. Yeah, there we go. Other input. Things are looking good. I have no complaints of what I'm seeing with this. 2-volt peak to peak input. Let's drop this down. Oops, wrong way. Obviously, we're clipping now because I had the gain turned all the way up. But, there you go. Well, this guy is repaired, so all I got left to do is just put the bottom plate on and package it up and get it back to the customer. So if you enjoyed this video, please let me know in the description. If you would have done something different, you let me know. I think I used a bit too much heat sink compound, and my heat sink compound's kind of getting old, so it's starting to separate a bit. But yeah, I'll get this button up back to the customer, and should be happy having an amp working for them. But all that being said, if you're new to this channel, please consider subscribing. Please give this video a thumbs up if you enjoyed the content. If you're looking for a repair, go to my description. You'll find my Google site in there. It'll tell you how to reach out to me via email, to download a document that you fill out, request for a repair, and we can go from there. All that being said, thank you for watching. Take care and goodbye.
Mark?